Here is a question on application of Ohm's law and dependence of resistance on length, area, material, temperature, etc. So the question states that this graph is a voltage versus current graph. Voltage versus current graph means a verification of Ohm's law graph. The graph is representing two resistors of same material, same radii with lengths L1 and L2. So these are the graphs which are drawn for two conductors whose lengths are L1 and L2. So there is a conductor whose length is L1 and there is another conductor whose length is L2. Since they are conductors but they are not superconductors, so they have some resistance also. That's why I have drawn like this. So L1 has a resistance R1 and L2 has some resistance R2. So the graphs are drawn for the two lengths L1 and L2. They have their own resistance R1 and R2. So if L1 is greater than L2, so if the first conductor L1 length is greater than L2, we have to state with reason which of the following graph represent voltage current change for L1. That means which of the graph represents for the conductor L1, means represents a resistance offered by that particular length of the conductor. So the graph is between current and voltage, and you know that slope of current versus voltage graph gives resistance. How to find slope? Very simple. On the straight line graph, you have to mark some 2 points and you have to draw perpendiculars on x-axis and y-axis and you get say points P, Q, R. So slope of voltage versus current graphs, slope of voltage versus current graph, that gives a resistance. How do you calculate slope? Slope is perpendicular, that is PQ, by base, that is RQ, that is resistance. PQ by RQ is in a way tan of theta. Theta is where this angle, that angle PRQ. So tan of the angle that the graph makes with x-axis, that is angle PRQ. That is a resistance. That means whichever graph is having more angle, that means more inclined, making more angle with x-axis, that graph has more resistance. That means that graph belongs to whichever conductor, that conductor has more resistance. Now in this case, L1's length is greater than L2, and from the graph we can clearly understand that graph B is graph A slope, means what angle it makes with x-axis is less, and graph B makes a greater angle with x-axis. So graph B is having more slope. So slope due to graph B is greater than slope due to graph A, and slope is more means resistance offered by the graph B or the conductor to which the graph B belongs, that resistor is greater than resistance due to A. And in that case, since L1 is greater than L2, and we know that resistance is directly proportional to length of the conductor. Long wires have more resistance, short wires offer less resistance. In that case, graph B has more resistance. So graph B belongs to the first conductor L1 and graph A belongs to L2. So since L1 is greater than L2, so they are saying that which of these graph represent voltage versus current change for L1. So for L1 it is graph B, because graph B is making more angle with x-axis. Slope of graph B is greater, resistance is greater, so its length also is greater. And since L1 is greater, so graph B belongs to the conductor L1. L1 offers this much amount of resistance, more resistance. And the graph A belongs to the conductor L2.